Okay, in this video, we want to talk about how to find the coefficients of a piecewise defined function such that the function is differentiable on the entire number line. Okay, and let's take a look at this type of a question here. So we want find constant, okay, a coefficient a and b such that the piecewise defined function and is differentiable on negative infinity to positive infinity, means on the entire number line. Okay, so what we have here, you can see this function is a polynomial. This also polynomial. Both polynomial means, okay, if you just talk about this piece alone, it's differentiable. You talk about this piece alone, is differentiable. But the question here, because that's, you have two pieces, you have to make sure in these two pieces joined together. Okay, join it together, make it continuous. Make it continuous. If function is not continuous, obviously it's not differentiable. So make sure that's continuous. And also, if it's joined together does not mean it's differentiable. If your function joined together like this, or like this, or like this, so that will not give you a differentiable function. Okay, but in order to be joined together and makes it differentiable, you see that must be the, you say if that's the x equals 2, must make sure and that's two piece connect and smoothly make that thing very smooth, so no any corners like this can't. So then that is differentiable. So how are we going to do that? It's easy to say it geometrically, but okay, algebraically, how are we going to do that? Okay, so first, as I mentioned, the function must be continuous. Okay, in order to make sure the function is continuous here, that means you limit x approach to 2 must be equal to the function value at 2 for this case. Okay, for this case. So now let's take a look here. Because the function is defined by two pieces, means piecewise defined. So you cannot directly find that limit. You have to find the limit from left and from right. Okay, so here let's take a look at limit from left. Okay, from left, so here x approaches 2 from left means x less than 2. So that means you're going to use this expression. So you have ax cubed. So you got a times negative 2 cubed, which is negative 8a. Okay, so then limit x goes to 2 from right. From right, x greater than 2. So x squared plus b. So here you have limit x goes to 2 plus x squared plus b. So you have, oh, that's positive. Okay, so that's positive. Okay, so here I have a 2 squared and plus b, which is a 4 plus b. If the limit exists, means this 2 must be equal. If limit exists, means this 2 must be equal. So we have the limit, you have 8a equal to 4 plus b. Okay, and also f of 2 is, if you use x equals 2, you use this expression. So you also find equals 8a. So that means this is f of 2. Okay, the limit equal to and the function value. Okay, it's 8a equals 4 plus b. Okay, that's we have the relation between and a and b. That's the first equation. But that's only make sure the function is continuous. Also, we want to find the function's differentiable at x equals 2. Okay, so here, let's take a look at the derivative. The derivative, so here, I can take derivative for the ax cubed. Its derivative is 3a x squared. But that's case you can only say x less than 2 because equal to 2 we are not sure there. Okay, so and for this case the derivative you have just 2x, then for x greater than 2. Okay, so now what do we have here? What do we have here? Okay, the limit at, okay, so here if you take a look here, not limit, f prime from left and add 2, that will give you 3a times 2 squared, which is 6a. So you use that piece. And the limit, the derivative from right, you're going to use 2x. So 2 times 2, so that equal to 4. So that's 2 must be equal. So from left and from right must be equal to make the derivative exist. So that indicate I have 6a equal to 4. Okay, now you can see here, I write that's two equations, this equation and this equation. So here together I have 8a plus 4 equal to 4 plus b and 6a equal to 4. And from the second equation, you can tell a equal to 4/6, which is 2/3. So now I put this 2/3 into the first equation. So I have 8 times 2/3 equal to 4 plus b. That's b. Okay, this is 16 divided by 3, and I subtract 4 from both sides. So I have this. And now let's take a look here. I simplify. Okay, I simplify this here. Common denominator 16 minus 12, which is 4. So 4/3. So now we can see here we got a equal to 2/3 and b equal to 4/3. So now your function should be like this, and 2/3 x cubed x less than equal to 2 and x squared plus 4/3 and x greater than 2. Okay, so that's how we try to find the coefficients to make sure the piecewise defined function is differentiable. First, we want to check if function is continuous. Okay, then we got an equation and it relate to a and b. Then we look here, the left side and right side derivative must be equal. So then we can determine, another equation. In that way, we can find both a and b there. Okay, and that's the end of this video.